All right, so we want to minimize the amount of paper to use. And now what I'm going to do is that we're going to use the white paper as our problem. We're going to ignore that brown border on there. Um, so let's start out by taking the dimensions of the printed area. So let's call that X for the width and Y for the length. So that area would be X times Y. Now we can use this along with the margins to come up with our area formula for the page. Okay, so you can see along the horizontal, they want a 1-inch margin on the bottom. So that means that if I have a 1-inch margin on the bottom, that means I'm going to get X plus 2 for the width, and then I have 1.25 margins top and bottom. So that would give me Y plus 2.5 when I add in the margins. So my area would be X plus 2 times the quantity Y plus 2.5, right? Okay, so now what are our constraints? Well, we want the printed area to be 30 square inches. So that means that 30 is equal to X times Y, and then we can solve for Y and we would get 30 over X. So that means my area in terms of X would be the quantity X plus 2 times the quantity 30 over X plus 2.5. All right, now at this point, this is a calculator active problem. So I'm going to go directly to Desmos because I want to minimize the area. So I'm going to find A prime and use the graph on Desmos to come up with my answer. So let's go to Desmos next. All right, so we want the minimum amount of paper to be used. So what we're going to do is we're going to use Desmos in order to find the derivative here. So in order to do the derivative, I'm going to go to functions, and I'm going to go scroll down, and we should get the derivative, if I can find it, under calculus. And then we're going to put in X plus 2 times 30 divided by X plus 2.5. Okay. All right, so if I look at this, we're going to throw out the negative, so we're going to throw out this side. But I can see if I zoom in here that I have a critical number at X equal 4.899. So let's just say 4.9. And I know that that has to be a relative min because I can see that on each side of 4.899, so on this side, the derivative is negative, and on this side, it's positive. So that means by the first derivative test that this must be a minimum. Okay, so we're going to go back and we're going to use 4.899 for our x value, and then we'll figure out what y is. All right, so if x equals 4.899, we're going to sub back into y equals 30 over x, and we get 6.124. Now remember, we are finding the minimum page length and width, so what we have to do is we have to add in the margins. So the bottom width would be 4.899 plus 2, so we would get 6.899. And then we need to add 2.5 to our y value, and we would get 8.624. So the answer would be 6.899 by 8.624. All right, another optimization problem. I hope that helps if you're seeing problems like this on your homework or in class. Thanks for watching. Please like and subscribe.